Good morning, everyone. I hope you enjoyed the previous 2 days of the conference as much as I did. So welcome to the third one and welcome to a, well, somewhat niche topic. I reckon that this would probably not be the ballroom type of audience, but so I appreciate each and every one of you who is interested in learning a little bit more about how to support stylus input on Android using the Jetpack Ink API. Now, let's start with a quick exercise. So, please raise your hands if you are using Stylus on Android at least once in a while. Okay. And those of you who do really use it frequently or just so what does supporting stylus input on Android actually mean, and how does Jetpack Ink API come into play? So the idea of Jetpack Ink API is to provide basic inking experiences on Android. Now the next question is, what, for God's sake, is meant by inking experiences? So there are a couple of use cases. I will be showcasing you two of them. The first one, if you have a Pixel, you probably know the circle to search feature. This is once you summoned up Gemini, you can draw on screen. And as you see, this is a nice sort of drawing that appears. And once the circle is complete, that Gemini will kick in and determine what was inside the circle and give you some information about that. And now the interesting thing with regards to Jetpack Ink API is that Google has done this part of circle to search using Jetpack Ink API. And Google is using the library also for some other topics, for example, for annotation purposes in Google Docs. And this is where the sort of second use case comes in. It's the traditional drawing experience. And this is what the sample app that is accompanying this talk is about. It's basically providing a couple of colors and two drawing tools you can select from, and then you can draw on screen. And here the drawing experience is the part that is handled by Jetpack Ink API. Now, you probably have guessed it, the QR code is a link to the GitHub repository. If you didn't have your smartphone ready, that's no problem. I will be showing the QR code again at the end of the talk. So before we dive into how we use Jetpack Ink API, we inevitably need to discuss, do styluses matter on Android at all? I mean, they are very popular among Samsung users, or a lot of Samsung devices come with a stylus, that S Pen thing, and also a few Chrome OS devices, particularly in the educational market, do come with a stylus. But basically everywhere else, styluses are a pretty much mixed experience on Android, meaning stylus support is sporadic and inconsistent. If you take a look at the devices, besides the Chrome OS devices that come from Google, you don't find too much styluses in the box anyway, don't we? So why I do think that supporting stylus is a very interesting thing. Styluses provide a premium experience. I mean, if you use a stylus on the device, it reminds us of the tools we have been using all the time. Writing with a pen or pencil on paper is just something we still are used to. And doing that also on smartphones and tablets, or particularly foldables, that is devices with a somewhat bigger screen, really is a nice experience. But there is also some more practical use case of this, meaning that a stylus offers a much finer control compared to, for example, touch-based input using a finger. And finally, there's another interesting thing. Styluses provide rich data, which includes pressure, angle, and tilt, which allows you to closely mimic drawing tools that we know from the physical world. So should we support styluses on Android? Yes, we should. We should take advantage of styluses whenever they are available. But, and this is the important part, we most certainly mustn't neglect touch input by finger and also by mouse. How do we do that? That's where Jetpack Ink API comes in. Jetpack Ink API abstracts away the complexities of graphics and geometry, which allows us to focus on our app's unique inking features, so not having to deal with the mundane and I can ensure you pretty challenging technical implications of this. One of these technical inclinations is the reaction time. So if we do some drawing on screen, we want that to respond as fast as we possibly can. So there shouldn't be any latency with what the user sees on screen when he moves the stylus, and this is something we don't want to implement on our own, and this is what Jetpack Ink API does for us. So they do the drawing with as less latency as they possibly can with regards to what the device offers. The first publicly available release of Jetpack Ink API appeared roughly about a year ago, early October 2004. As of September this year, we have a release of 1.0.0 Alpha 06. One important thing to keep in mind is that Google is currently updating the documentation and the samples. Why am I deliberately mentioning this? If you take a look at the official links, they don't fully cover the latest Alpha 06 release. I'm happy to say that my sample app does. So if you really want to know what you can do with Alpha 06, please take a look at the sample code. And I heard from a Googler that they are currently updating their documentation, so they should follow very soon on this. Now, why should we use Jetpack Ink API? I mentioned that already. It leverages the benefits of a stylus, but it also works with finger and mouse input. It has a modular design, which allows you to pick and choose the components you need rather than forcing us to some big monolithic architecture where we have to learn a lot before we can really take advantage of the library. Now, I know this sounds great on paper. I will be showing you a lot of code in the subsequent slides, so you can judge for yourself if my hypothesis here is correct. Currently, there are 6, if you want, logic modules. The most basic one, strokes, which is the foundation of the library. It represents the ink input and its visual representation. Then there is the brush module, which defines the look of your strokes, the color, thickness, and style, for example. Rendering helps you to efficiently draw on screen, ensuring that it looks great on both Jetpack Compose and Android views. I will be returning to this a little later, because in previous alphas we had the sort of pleasure of using Android View and a really, really big chunk of code related to pointer input and stuff like that. This is also what we find in the current documentation, but fortunately this is now no longer needed. There now is a nice composable we can use, which does all the heavy lifting for us. You will be seeing this shortly. 3 more modules to cover. Geometry, this is the one you will be needing if you want to do things like erasers or selection stuff. This is a somewhat advanced topic, so I'm not covering this here in the talk. Authoring is the module that does the input capturing for us, and finally storage. This is a rather new one. This is a module we need when we want to do either long-term persistence, meaning save the drawings of the user. This is something I do not cover in my sample, but what I do cover in my sample is sort of short-term persistence, meaning reacting to device rotation. So if the user turns the device, we certainly don't want to lose the drawing, and my sample shows you how to do this using the storage module. Now let's take a look at the implementation. So as you can see, the list of dependencies nicely blends in with the logical modules I mentioned. So we have the authoring, we have the brush, geometry, rendering, strokes, and storage. So this is the set of dependencies you probably want to include when your app should be using the Ink API. Now let's turn to some really code. This is the start of the implementation process on an activity level. So we just have a full screen composable, which is the one we will be dealing with in the subsequent slides. Now, As you can see here, there appears to be quite a lot of code, and you don't need to try to read it. So I put it in fine print deliberately because this is code that is really not related to the Jetpack Ink API. So let me quickly walk you through this. So we have the inevitable scaffold, which is sort of the root composable, basically any Material 3 or Material 3 expressive app should have. Then combined in the column, we have custom color selector I implemented. We have a custom tool selector I implemented. And the biggest part of the screen is covered by what I call the drawing surface. This is the thing that's interesting. This is the thing that we'll be taking a look at in closer detail. So this basically covers half the code you probably cannot read on screen, but there is another part where you may be wondering, what's this about? Well, let's have a look. These are the bits and pieces that sort of prepare the usage of the Ink API. So what we have here is I'm maintaining a state which I call finished strokes. This state will be passed to the drawing surface composable, and this state contains a list of finished strokes. Just keep that term finished strokes in mind. I will be explaining what this means a little bit later. This is the part that is necessary to gracefully react to device rotation. So I'm using a custom saver implementation. Here is a helper class I wrote, serialization helper, which basically persists the finished strokes. This is the other term you will be hearing a little bit later, using a savable. The second important state we will be using is the brush. So the brush really is the most important thing when using Jetpack Ink API, and this brush is populated by two states. As you can see, we have a current color and we have a brush family. These two states are populated by the two selectors I showed you. So I have a color selector that obviously changes the current color, and we have a brush family which is populated by my tool selector. This is just a humble enum class. Here it has just two enum values which represent the two tools my sample app has implemented. So, and these two states contribute to the state that's actually used in the drawing surface. As you can see, it is created by brush.create with color int a RGB. There are other ways to create a brush, but this is a pretty convenient one because it gets four important properties that are needed to create the brush. The most important one being the brush family. As you can see, what I'm doing here is just mapping my enum states to one of two stock brushes, one being pressure pen latest and the other one being highlighter pen latest. As you can guess from the name, the first one implements a pen. Pressure sensitive indicates that if you are using a stylus, depending on how much pressure you put on the screen, it will influence how the stroke will look like. Certainly this does not work with your finger, so don't harm your fingers by pressing. It won't make any difference. Then obviously the color, the size, which influences how big the stroke will be. And then there is this epsilon value, which is a sort of detail property which is used if you implement zooming in features. I'm not doing this in my sample app, so I'm using this with the default value that Google suggests us to use. So what you should take away here is that the epsilon value in a way influences how much you can zoom in, and the bigger that value is, the more memory will be consumed. So when you are implementing a drawing app and you want to do some real heavy zooming in, you sort of need to play with this epsilon value a little bit to see how you can balance memory consumption and the zooming experience. Before we come to the next slide, I would like to highlight one more thing. You probably have wondered why that thing is called pen latest. So Jetpack Ink API sort of versions the tools. And if a brush ends in latest, this means that the app wants to use the latest and greatest implementation, which implies then Google takes the liberty of changing the behavior of a brush when they see fit, whereas if you use a particular version, for example, 1, then this means that no matter which version of the library you use, the behavior of the brush will always be the same. Now let's take a look at the central composable My Drawing service. Again, to remember, here we have the two states I mentioned, finished strokes, which is a collection or more particularly a list of strokes. Then we have the brush, and as you can see, it doesn't do much. So that callback that is passed in it does nothing but populate the list once the drawing is completed. So remember that I mentioned there are two sorts of stroke types, the one being the in-progress strokes. They are handled differently than the finished strokes. So what does that mean? While a drawing action is in flight, in progress, Jetpack Ink API handles this for you. This is done, for example, to ensure that the drawing looks particularly smooth. And once the drawing is completed, there no longer is the need for Jetpack Ink API to handle that stroke. Then it is sort of moved to the list of finished strokes. And this is where the second composable comes in, which just renders the finished strokes on screen. Now, the inclusion of this one is really hot. Remember, I said at the beginning that previously we had to use a custom Android View implementation, do a lot of the heavy lifting by handling pointer input, and you can see that in the Git history of my sample repo, because before I switched to this new composable, I had it in there. And also the Google documentation that is currently available shows this old way of doing this. I'm really happy that this is no longer possible, because as you can see, it's really easy and nice and simple. This is the way things should be. The finished strokes composable is pretty easy. It's basically just drawing on a canvas. As you can see, we pass in the list of finished strokes, and we pass in a strokes renderer. It's created like this. So this is just some boilerplate code. You need to know that it's there, but no much need to deal with it. And the main thing the composable does is basically iterating over the list of finished strokes and just making sure the strokes are put on the canvas. This code gets a little bit more complicated if you decide to implement zooming in features. Then these transforms come into place. But unfortunately, this is too much of an advanced topic to cover here in this lightning talk. So you need to take a look at the documentation. Unfortunately, there is not much there yet, so I hope Google is updating this to showcase this advanced usages. And that's basically it. So let me wrap up a little bit for you. My personal experience with the library has been great. It works great, and it actually is fun to use. There are some areas that still look and feel a little bit bare bones. For example, writing the code that does the persistence is a little bit basic. So there are the basic building blocks are available, but it doesn't look particularly fancy. But that's part of the philosophy, that something that Google said they want to get the basic part as stable and as fast as possible, and then add more of the fancy stuff along the go. And this is what we have seen with regards to that, moving away from having a custom Android View implementation, and now instead of this, providing a nice composable that does the in-flight stroke handling for us. And I think we will see much more like this in the coming versions. If you are interested in taking a look at Jetpack Ink API, there are a few things you may want to take a look at next. I mentioned this a couple of times, persistence and state preservation. There are some basic capabilities there in the storage package. Again, I'm repeating myself. I show you how to do this with a sample app. Editing and erasing, there is also support available through the geometry package, but so far Google's documentation doesn't mention much about this, so I really hope they will be updating this and adding more stuff. This also applies to zooming, so as far as I know, there is nothing there, so at the moment you are on your own to find out how this works. A list of resources, the first one being the official introduction of the library, the Android developers blog post. Then we have the API reference, and the sort of documentation. This is not a real code lab, but it shows you the most important bits and pieces that you need to do, which is basically the same as I am doing here on the slides and in my sample, with a notable difference that my source code being up to date, meaning fully covering Alpha 06, whereas Google samples still need to be updated. Finally, fellow developer Nicolau has done a nice GitHub repository. It's worth taking a look because Nico does long-term persistence using Room, so make sure to check out his repository. You can find both the source code and the slides as a PDF in the GitHub repository, so if you're interested, take it with smartphones and scan the QR code. I hope you enjoyed the talk. If you have questions, I will be around the whole day, so feel free to reach out. Happy to chat about it, and thanks for listening.